Well, good morning, good afternoon, and welcome in from across the continent and beyond today for another very exciting Exploring by the Seat of Your Pants broadcast. If you're new to us, and so many of you are today, we are all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us on a very exciting day because, as part of our commitment to conservation in partnering with the amazing members of the IUCN and Reverse the Red, we are doing an epic series today for the second time ever. Last year, we partnered with the amazing folks at the Canadian Wildlife Federation. They are Canada's leading conservation organization for an incredible series during National Wildlife Week. And it went so well that we just had to bring it back to all of you. I can't wait to get underway with this. I encourage you to check out the full lineup with 4 other amazing programs every day at noon Eastern throughout the week. We're going to be going live every single day, and they're going to stay on YouTube forever. So you can catch them in 2 weeks, 2 years, anytime you want to learn from some of the world's coolest experts. You can join us for some very neat stuff. Now, before I get underway, I want to note we do have a Kahoot today. So between our talk and our Q&A, if you want to play along with a little 4-question quiz to test your understanding and have some fun, you can pull up that game pin below and join us for a little bit of adventure. Now, without further ado, I'm so excited to welcome in Nick Lapointe from the CWF. Today, he's going to be leading us off with a talk on freshwater fish and specifically salmon migration and conservation. We have done a bevy of salmon programs over the last year. It's a topic of huge interest to Canadians from coast to coast to coast, and I'm really excited to welcome him in for the first time to share a little bit about his expertise and passion. So Nick, thank you so much for joining us today and welcome to the broadcast, man.
Thanks for having me.
Awesome. Well, I'm going to zip it because I've been talking for a while. I know you've got a lot to share with us, so feel free to dive us in and take us away.
That sounds great. Well, thanks everyone. My name's Nick. I work with the Canadian Wildlife Federation. I lead our freshwater program, and I'll do my best to share some interesting things about fish and their migration, especially salmon, but want to leave lots of time for all of you to ask questions as well. So I'll try not to go on too long. But here's an example of a huge Chinook salmon. They don't all get this big, but they are the biggest migratory salmon. They're a Pacific salmon. And just to get some of the scientific terms that we use in ichthyology, which is the study of fish, diadromous fish are those that migrate between saltwater and freshwater. And salmon are anadromous. So they spawn in freshwater and then they swim out to the ocean to complete their life cycle. And I'll show that in a minute. This map at the bottom is a map of one of the places that I've done field research on Chinook salmon in the Yukon River. And this is the longest salmon migration in the world, over 3,000 kilometers. So really wild what these fish are able to migrate at the end of their life. There's one other form of diadromous fish, and that is catadromous fish. And these are fish that spawn in saltwater and then rear and grow up in freshwater. And there's one catadromous species in North America. And I'll see at the end of this talk if anyone who's asking questions knows what that species is. And if not, remind me and I'll let you know. But then we have a whole bunch of pentamidromous fish. And these are fish that migrate within freshwaters. And really, probably half the species in North America make some form of migration. Some of these are things like northern pike that might make a very short migration into flooded wetlands in the spring to spawn. And others like walleye here can make migrations of hundreds of kilometers, same with sturgeon, to reach their spawning grounds. So even within freshwaters, you have species of almost every type that make migrations. And so fish need to move around fresh waters. The rivers and streams are their highway network, and that's how they get from place to place to make use of different habitats at different life stages. So to talk about Pacific salmon for a minute, these are all native to the Pacific Ocean. They've been introduced to other places, including the Great Lakes, where they can complete that full life cycle only in freshwater. But there are 5 species of Pacific salmon in North America. There's sockeye, coho, and chinook that are the longest lived, and then pink and chum that are more short-lived and smaller bodied than the others. So, if you've had lots of presentations on salmon, you probably understand that they're laid in redds. That's the spawning beds and gravels. These eggs are laid in gravels. When they hatch, they hatch out as fry, and then as they get bigger, they become smolts. And as this is happening, they're migrating out to the ocean. So chum and pink salmon go right out to the ocean the same year they're born. The other species can overwinter in freshwater and then go out the next spring once they're a year old. And then they'll spend that time in salt water, out in the ocean, growing. If you've ever seen that silver-colored salmon, that's the life stage that they're at. Those pink salmon will only take 2 years. They'll come back in 2 years as full-sized pink salmon, adults like that. The other species can stay 6, 7, sometimes 8 years out in the ocean before they return. And as they return, this is when they make that migration back to the rivers, and they start to transform. So they'll become bright colors. They're no longer silver. Sockeye have that bright red body and the green head. The males start to develop this hooked jaw called a kype that they use to compete with others for mates when they're spawning. And as they travel up rivers, their bodies transform like this. And they finally reach spawning grounds. This is a picture. You can just make out those red lines. Those are the Chinook salmon that made it all the way up the Yukon River. And this is an area that they've cleared out, those gravel areas where they're going to lay their eggs. And unlike some fish, like Atlantic salmon, that can spawn and then go back to the ocean and come back in later years to spawn, Pacific salmon are semilparous, which means after they spawn, they die. Their carcasses help to feed bears and eagles and renew the stream in the forests, and the eggs are laid, and that life cycle continues once again. So these fish, particularly migratory fish, face all of these threats that other freshwater organisms face. Of course, climate change and contaminants, habitat alteration, invasive species are the big ones. Depending on the species, overfishing can be an issue. Aquaculture is a real issue for Pacific salmon, particularly these fish farms that are out in the ocean and not contained in the building. But the one that I work on the most is the barriers. And so you can think about these fish, if they need to migrate from the ocean to freshwater, if you put something up in their way, that's a real problem for them. And so this is a pretty iconic picture of a dam in Washington State that was removed about 10, 15 years ago. And this picture was taken in the 1970s by the photographer. The photographer is the person who, in the middle of the night by themselves, put on some mountain climbing equipment, rappelled down this dam, and spray painted this crack on and spray painted Elwha Be Free. So they wanted to free the Elwha River. And it took 30 or 40 years, a lot of indigenous tribal campaigning and efforts, and these dams were taken out, and the recovery of that ecosystem has been tremendous. Tens of thousands of the salmon have returned, not returned, but the populations have grown to tens of thousands just in that river since those dams were removed. So this is something we try to work on in Canada. We're behind in terms of dam removal compared to the US, but there have been some big dam removal projects. It isn't just dams though. Fish are blocked by all kinds of things. Dams are the most obvious, but everywhere the road crosses the stream, if it's not a bridge, it's likely a culvert like this. And if that culvert, this round pipe here, is too small, what happens is whenever there's a storm, the water chutes get pushed out of that pipe, like when you put a nozzle on your hose and you have that hard spray. And what that does is that erodes, it pulls all this material below the culvert and eventually digs out the stream underneath. So the culvert has a drop on it. Fish can't jump that drop. Even if they can, it's hard for them to swim down through here. So a lot of these are a problem. And then you have things like dikes and levees on the sides of rivers and lakes that block off things like those wetlands that pike spawn in, that fish need to use at different times of their life cycle. And then, of course, you have these natural barriers like a waterfall. So if this was a salmon stream, naturally salmon might come up all the way to the base of this waterfall, but there would be no salmon upstream of the waterfall. For freshwater species, you could have a population that survives and lives and is contained upstream of that waterfall and a different population downstream. So naturally, rivers can have barriers on them as well. The problem is when we add more barriers, we break them up into smaller and smaller pieces, and less habitat is available to those diadromous species that need to be connected to the ocean. So as a science-based organization, one of the things we first need to do is we need to understand the problem. And we've worked hard to create a database of all the aquatic barriers in Canada. So far, we've mapped out 36,000 dams, 25,000 waterfalls, and over 1.5 million culverts. So I should say of these culverts, not all of them are likely to be problems for fish, especially if they're on very small streams or upstream of a waterfall. We're thinking there's probably more like 500,000 that are a problem. But we've only managed to find 400 fishways, and there's probably not that many others in Canada. And so a fishway is like a fish ladder. It's a way for that. It's something that humans can build to help fish get around an obstacle. And so compared to the number of dams and culverts here, we really haven't built very many fishways. So we need to change that. Here's what that map looks like all across Canada. And I know there's some callers here from the US, from Pennsylvania and New York, I think. And anytime we've got a watershed, water that flows between the US and Canada, I'll talk about that term in a little bit. We've mapped all the barriers down into the US as well, because fish don't understand the border. They need to move between these systems. They need to follow the rivers wherever the rivers go. So you can see, if you zoom in here, you can get right down to your city, your neighborhood, your place of the world where you go out into the country and fish and hunt, and you can see all the barriers that have been mapped. And we're still trying to work to improve that. And so what we're doing right now is we're building a community science mobile app that by June, all of you should be able to download if you're interested, and you'll be able to look at your neighborhood on the map, and you can see red ones that are red squares or confirmed dams. Green dots are a place where a road crosses a stream, but we know it's a bridge, so we know fish can get past. And all the purple ones are the ones that we don't have any information about. So we're hoping that people who go out, especially people who go out fishing or canoeing or go hiking around rivers and streams, can go and help us by going to those purple dots and taking 5 minutes to just take some pictures, make some notes about it, and let us know what you see. But there's also probably some dams and some waterfalls that we don't even know exist. And so if you can find a structure like that, find a new waterfall with this app, you can take a picture of it, add it to the map, and that'll add to the numbers that I showed you earlier. So hope by June this is available, and that we can get lots of help in finding these barriers and understanding the situation. So I'm going to switch gears a little bit from all the barrier data that we're collecting to what we're doing with it. But before we do that, I have a question for everyone, and I'm not going to ask anyone to answer it. Just think in your head. If you think about a river, what organism, plant or animal, or bacteria or anything like that comes to your mind? What do you think most looks like a river or resembles a river, is like a river?
A little lizard friend jumps to mind for me, Nick.
Better guess than the typical answer that I get. People think of rivers as snakes, right? Their rivers are described as snaking, and there's reasons that rivers curve back and forth like that. But when I see a river, I don't think of a snake. I think more of a tree, because a river isn't just one main stem. It's all the tributaries to that river, which are all the streams that flow into it, and all the streams that flow into those. And so, that is essentially like a tree. And this is really important when you start to think like a fish and think about where those barriers are and what to do about them. And so this is that term watershed that I mentioned earlier. And some of you have probably heard that. The reason that we think about rivers this way is it's not just the river, it's not just the branches of the river, but it's all the land between those branches. And we call it a watershed because wherever the rain falls, when rain falls somewhere, it's going to drain somewhere. It might pass through the soil at first, but eventually it's going to end up into a stream or into a river and flow down that river into another one, and into the ocean. And so you can see sort of these aren't all joined watersheds, but all of the Great Lakes here, for instance, all flow out through Lake Ontario and down the St. Lawrence River into the ocean. And so if you think of this tree, then you think of the St. Lawrence River as the trunk of that tree, and then all the other rivers and streams in the Great Lakes are the branches of that tree. And so if you have barriers, well, there's a big difference as to whether that barrier is way up here and only blocking off some of the branches up in this corner, or if the barrier is right across the trunk of that tree, because that's the highway for fish to get into this whole watershed and all the streams and tributaries of that river. So we use that in trying to go to a watershed, and I'm going to give you an example from the Horsefly River watershed in British Columbia, where we've done some of this work. So this is a branch. It's a tributary to the Canal River, which is a tributary to the mighty Fraser River that flows all the way through the middle of BC out through Vancouver. And this is about 700 kilometers up from its mouth. And this is a salmon river. So salmon go all the way 700 kilometers up the Fraser, into the Canal River, and into the Horsefly. And they come in up around this top corner, and they can make it through this river network through all of these branches to different parts of the river. And when we got there and we looked at the maps, we saw that there were 2,500 potential barriers, mostly culverts, road stream crossings, but about 9 dams as well. And we realized this isn't something we can deal with. We can't put in 2,500 bridges. This would take a lifetime and a fortune to do. So we needed to refine this. And the way we did that is we said, okay, well, where can salmon go to? We're bringing the science in here. We said, okay, well, salmon aren't going to be able to get over a waterfall, and they also can't climb the side of a mountain. So let's find the parts of this watershed that have natural barriers where salmon historically never would have been able to get to beforehand. So there's a waterfall here, for instance, and that all this stuff in purple is areas that salmon wouldn't be able to reach, whether or not there was a dam or a culvert in the way. So that really narrows it down. And then we can also think in that area that salmon could reach, well, some of it they're just going to use as a highway. They're not going to spawn there. They're not going to overwinter in that area. And so we wanted to find the barriers that were downstream of this lighter blue, thicker area, which is the habitat that would be suitable for salmon to use and not just a movement corridor. And when we look at how many of those 2,500 possible barriers, without having gone out and looked at them in the field, were downstream of that usable habitat for salmon, well, now we're only down to 109. That's a number we can go out and look at in the field. And so we go out and we assess the barriers, we assess the habitat, we find out how many are actually barriers, and it turns out in this watershed that we thought might have a ton of barriers to salmon, well, right now, 93% of their habitat's connected. So almost all of their habitat's connected, and there's really only a few barriers of concern. I think out of that 109, there were only about 45 that are actually barriers to salmon. But for the older kids here who've learned how to read these graphs, the story gets even better. And that's if we want to, there's 7% of this disconnected habitat. So if we want to get half of that back, not all of these barriers block the same amount of habitat. You can see some here have a lot upstream and some just have a tiny amount. And so, the first barrier blocks 5 kilometers of habitat. The next best one blocks about 4, then 3, then 1. And by the time you get up here, those last 10 barriers or so, they're only blocking like 50 meters, 100 meters of habitat. So really the good news story here is that of all the habitat that salmon can't get to right now, if we could deal with just 5 barriers out of those 2,500, we could get half of that back. And so doing this sort of thing is really making this wicked, crazy problem of too many barriers, don't know what to do about, into something that's much more solvable. And when we find those barriers, then we can go and do these restoration projects, construction projects to either remove them or improve them. This is one at low water level. This is a problem. At high water level, fish can get through it. We ended up taking this out and taking the whole road with it because that road was not being used anymore, and we could restore a natural stream bed. Same here in PEI. So this is one of the ones that we found through that planning work in BC, and this is one with a similar process that we applied in Prince Edward Island. The other thing we can do if this is a road that does need to be there, well, we can take this culvert that was too small. You can see there's not a lot of water flowing through it for fish to get through, and we can replace it with either a bridge or this is sort of an arch. And the really neat thing about this is now the stream can move and snake underneath that arch, and other wildlife, terrestrial wildlife, can use this as an underpass. So they can travel under it without being hit by cars as they cross the road. So this solves terrestrial and freshwater fragmentation. Or we can do things, you can see this little these steps here. This is a fish ladder that was put in to help fish get around a barrier that you can't quite see. This is more of sort of a natural fish ladder. And of course, fish couldn't swim up that right now, but when the water level's high, when they're migrating, fish can now get into this culvert when otherwise this would be a jump that would be impossible for them to make. And then the other thing that we do is we engage in a lot of advocacy. So we work with the federal government, who's responsible for fish habitat. There's a law in Canada called the Fisheries Act that makes it illegal to alter, harm, or destroy fish habitat. And unfortunately, that law isn't always being enforced. So a lot of these dams and culverts are altering or destroying fish habitat, and they haven't gotten an exemption from that law. And so there is a pathway to require the people who own these to replace them. We would also like to have funding to do more of these projects. And so we think nationally we need an entire fish passage strategy to remove 1,000 of those barriers by 2030. We'd like to push to make the federal government and the provincial governments make that a reality, to take out their own barriers, require companies that own barriers to remove them. And we're really excited to help find the most important barriers, to try to find the 1,000 most important barriers in Canada for people to address. So that was all a little shorter. I probably went a little quicker than expected, but that just leaves plenty of time for questions. And I'd be really happy to discuss that with all of you and discuss some of the other migratory fish and fish conservation concerns, and see if anyone has any ideas about the catadromous species that is born in saltwater and migrates to freshwater.
Yes, that could be our first query before we get underway with our Kahoot too. So if anyone wants to share that in the chat, what they think it might be. I have a thought, but I'm not sure if I'm right. I used to work at Ripley's Aquarium, so we were surrounded by a lot of Canadian fish in the first part of that. It's a pretty special fish if I'm correct, but I'll leave our audience to take a look at that. Nick, if you want to come out of screen share so you can see us have a bit of a conversation, I'm going to bring up our Kahoot pin again. So we'll start with 4 quick questions for you guys to have a little bit of fun with who is paying attention on some broader topics within freshwater and freshwater fish. And then we are going to dive in with a really, really nice Q&A together. So for those who are new to Kahoot, the faster you answer, the more points you get. And what you win is Nick and I's everlasting respect. So no pressure at all. And Nick, if you want to help us out with hints as we go along through this, you're welcome to chime in as well. Always welcome. But we're going to get underway in just a second, and we'll go from there. Catadromous is your query 2 in the chat for everybody. But let's get started with question number 1. All right. Dun, dun, dun. Drum roll, please. 3, 2, and 1. And there's many more water-themed Kahoots on our channel if you're so inclined at the end. What percentage of the world's water is fresh? We didn't explicitly talk about this, but I'm really curious what people think. I remember learning this in school, and this blew my mind. Is it 80%, 50%, 20%, or under 3% of the world's water is fresh? And particularly fresh like rivers and streams and lakes, things that when we think of as fresh, you know, my mind doesn't go to glaciers, even though glaciers and ice caps are a big proportion of what our fresh water is. But wow, Nick, they're killing it. Most of them got this right, which is fantastic. Yeah, most of the world's water is locked up in the ocean, salt water, but under 3%. Do we have a figure on the amount that's in streams and rivers and ponds and whatnot? Is it?
That's a good question. I think that counts all the glaciers, all the ice caps, all the lakes and ponds, all the groundwater that you never see that's underneath and is flowing where you don't see it. So all of that makes up less than 3% of the water on planet Earth.
I love this next one too. How many kinds of freshwater fish are there? So we've been talking about species number in a few of our broadcasts lately. Is it about 300, 1,000, 2,500, or over 18,000 kind of freshwater fish? For comparison, by the way, mammals, so all antelope, primates, bats, mice, all of that is about 5,500. And we had a complete, almost even split in this. But yeah, Nick, there's a lot of freshwater fish in the world. There's over 18,000 species. In Canada, do we know how many we have total? Is there a figure on that?
Anyone who answered about 300 is pretty right when it comes to Canada. A lot of those species are found in tropical waters, so we don't have as much fish diversity as places like Brazil and the Amazon River have. There's more species in probably one tributary of the Amazon River than in all of Canada.
That's true for pretty much all the kind of species. When we do butterflies and birds, it's mind-blowing how much are in like Costa Rica, for instance. So, all right, Legend Jaguar takes our lead. Let's see, with 2 more questions to go. True or false? Atlantic salmon return to the stream they were born in to spawn. You talked about returning to streams at the beginning of the program, and I think this is something that like a lot of people know. This, for whatever reason, this is like a idea in conservation and nature that just seems to have stuck with a lot of people. So I think we're going to get a lot of correct answers on this one. We got 5 seconds to go. I found it really interesting when you mentioned that Pacific salmon die, but Atlantic salmon can go back several times. I think a lot of people don't know that. I think we've sort of seen the bears eating them on the west coast of Canada and, rivers full of dead salmon. So is there a limit for how many times Atlantic salmon can do that? Do we know that?
Yeah, I mean, it would usually be 2 or 3, and it's not that they would all do that. It takes a big toll on them to make that migration. And at the end of the last one, they're going to end up dead on the side of the streams as well, and bears are going to eat them. And I would just add to this that this is one of those mostly true, because salmon do sometimes stray. So something like 5% of the salmon end up going somewhere else. And that's they've evolved that way, and it's really important because if salmon are eliminated from the stream, they need to be able to recolonize it. Otherwise, how would they find those streams in the first place? So it's built in that almost all of them return to where they were born, but some of them go exploring.
I'm so happy you mentioned this. This happens with turtles as well. A lot of people know that they go back to the sort of natal beach. Our favorite example of this ever, we had a puffin migratory route on one of our things, and they tracked about 500 of them, and one of them went inexplicably to like the Italian coast and just stayed there. And I was like, that's a very interesting puffin. Good for them. All right, our final question for all the marbles, and then we are diving with our Q&A. What can you do to help freshwater fish? We talked about a lot of solutions that governments didn't do and big organizations like Canadian Wildlife Federation today. For you at home or in your classroom, can you tell your friends and family what you learned today? Can you choose sustainable seafood? Can you help take action to fight climate change, or all of the above? Nick, you had a great slide of some of the threats facing fish early on in your talk. So who is paying attention to some of those threats? Maybe some of these could really fit those. Let's see. Yes, all of the, if you ever do a Kahoot with me, all of the above is always the correct answer. I'm very shameless that way. So you can keep that in mind if you join us for the rest of our series with the CWF. All right, Space Lion is third. Second is Mighty Penguin. And first, drum roll, is, let's see, Lucky Koala. Well, way to go, guys. Thank you all for playing along, and I hope you learned a little bit from that. And Nick, we're going to dive in with our Q&A now. So our first question from our Pennsylvania friends is, how big salmon can get, and what do they eat?
Yeah, so that depends on the species. A big pink salmon might be about 5 pounds or so. A big Chinook salmon can be over 100 pounds, but these days finding one over 50 pounds is very rare. We've fished away a lot of the largest ones, unfortunately. They'll eat different things at different life stages. So the little fry and smolt, the little baby salmon, are typically going to eat a lot of aquatic insects, maybe invertebrates, maybe plankton even. When they get bigger and they go out to sea, salmon are predatory fish. So they're out there eating smaller fish like herring that are swimming around in the ocean. And this is the difference between Atlantic salmon and Pacific salmon, is that once those Pacific salmon become adults and start returning on their migration, they stop eating. They'll never eat again when they come back to freshwater. But the Atlantic salmon will eat in freshwater because they're going to go back to the sea after they spawn.
I love when you highlighted at the beginning that they change when they come back up to breed, like the hook nose, the cool colors. I mean, we've got a picture here right on the backdrop. And I mean, it's so weird. I think most of us think of like butterflies as something that changes, or, a tadpole to a frog. And the fact that fish go through this remarkable transformation as adults is really interesting in the animal kingdom. So thanks for the backdrop, Nick. Also, that Chinook, before he went live, Nick and he showed me the picture of the amazing fish in the hands. And it's one of the greatest fish pictures I've ever seen. It's remarkable. So thanks, Mr. Tomlinson's class. All right. A great question. Should we eat salmon? If we finish this broadcast, we've learned from you some of the threats facing them. Should we eat salmon? Is there a sort of benchmark for this, or any nuance with this question?
You should, but it's very nuanced. It's very hard to find what salmon you can eat. So wild-caught salmon won't be Atlantic. They'll be Pacific salmon, usually sockeye or pink salmon. Especially canned pink salmon is really common. And for the most part, that's a good fish to eat, but it can be hard to find wild salmon. If you're eating like a salmon fillet, a big piece of salmon meat that wasn't canned, it's almost entirely Atlantic salmon that's been farmed. And the real question there is whether that Atlantic salmon's been farmed out in net pens in the ocean, which are extremely destructive to habitat and disease transfer to wild salmon and so on, or if it's been farmed in a building. That's called closed containment aquaculture. If it's been farmed in a building, we can control their waste. They don't escape out into the wild, and that's a much more sustainable way of farming salmon. Though even then, we have to feed them a lot of fish pellets, and it takes about 5 pounds of fish to produce 1 pound of salmon. So it's kind of like farming wolves instead of farming cows.
Interesting.
So there's a lot of challenges. There's a lot of really good salmon to eat and important to eat salmon to keep the people who manage their salmon well. Managing those salmon well, but you got to be really careful.
It's really interesting because our kids have grown up in an era where aquaculture is absolutely huge. And when I grew up as a boy, it was like, oh, aquaculture is this thing that's going to completely change the game and make everything better. And we're going to stop having to, harvest the ocean. And there's been a lot of problems highlighted with it over the years. And so you've talked about quite a few of these. Is there, as a quick follow-up to this, is there an example anywhere in the world of like really good, well-managed outdoor in the ocean aquaculture? Like, can that be done? No.
Can't be done. Can't be
Okay.
done. But there's some really good aquaculture. If you buy tilapia,
Yeah.
that's farmed. If you buy farmed channel catfish, and one of the reasons that those are both, they're done inland and they eat plants, so we can raise those fish on plant pellets, and you don't have the same energy conversion issues, and that's a lot more like raising chickens. So eat tilapia. That's a great sustainable aquaculture option.
I love the thought of farming wolves as a comparison to it. That's really fascinating. That might stick with our kids in a really good way. So thanks for that. I will say too, on the sustainable seafood front, for our American friends, Marine Stewardship Council for Canadians Oceanwise. So we've highlighted these in a bevy of our broadcasts in the past. So if you go to a restaurant or a grocery store, you'll often see sort of symbols from, again, the American side is MSC, Canadian side is Oceanwise, where at least some research has been done by trained professionals to sort of highlight what the fish are that if they're sustainably harvested. So I encourage you to look for those when you're choosing seafood, because you can help make some, at least some informed decisions. Do you have any comment on this? Because you look like you're, please do comment away.
You know, you have a lot of greenwashing. So there's a lot of, almost every seafood product you buy is going to have some sort of label that makes it sound or look sustainable. You know, if you really want to make a difference, you're going to have to learn about whether that is a good one or not. So look for some of the big environmental organizations. The Vancouver Aquarium is a good example. They have, programs, and trust something that comes from an aquarium that's focused on conservation, or a conservation organization, more than just, an icon that makes it look like it's sustainably harvested.
Absolutely. I will say Oceanwise spun off of Vancouver Aquarium. So that is their specific project, which is why we highlight them. But I'm really glad you mentioned that too. Nick, you're going into the weeds here, man. We got greenwashing covered. We've got aquaculture as universal bad. I like it. All right. A great question online. Have you encountered flooding as an issue in any of your work? And if so, how do you correct that issue? So we talked about low water in a few of your slides. How about too much water? What's the deal?
Sure. I mean, flooding is part of rivers, and it's a problem working around rivers. We had those big atmospheric rivers in British Columbia on years when we plan to do construction projects, and you can't work, so you got to wait until the next year. Flooding is super important for fish, right? It creates a lot of their spawning habitat, depending on the species, or places that they can use as refuge during really warm or low water conditions. That's when habitats form. So those culverts, they don't just dig out gradually like that. All that erosion happens and the culvert becomes perch when there's a flood, when there's a high water event and water comes rocketing out there as a cannon. So the more we try to do to control flooding, it's very much like trying to control forest fires. And then because you control forest fires for so many years, there's too much wood left over. And when it does catch on fire, it becomes way more dangerous. So we can have the same issues if we try to control flooding. If we change the landscape, change that watershed, the flood and its damage, when it does occur, can be even more severe. When it comes to barriers, a lot of those are tied in. You think of dams as things that can help with flooding. Well, most dams don't have a lot of capacity to store more water during a flood. They just let water pass through. And older floods and undersized culverts like that, are at risk of damage from floods. And so we can actually improve society's preparedness for flood and reduce roads being washed out, reduce dams being washed out, which can, be a real risk to people. People can get killed in floods like that. If we properly maintain our infrastructure, make those crossings big enough so that the stream can pass under them, even in a flood. If we do that, it's good for fish and it's good for people. It doesn't wash out.
What a great answer. Also, I've never had anyone talk about floods in that way like they do for forest fires. We've done a lot of forest fire programs to talk about the fact that we've managed them a little wrongly. Parks Canada has done some great series with us on that, but that has never come up in one of our programs. So that's very neat. All right. You talked about fish staying in their stream for a while before they go out to the ocean. How do fish survive the winter in Canada? What's the deal?
Fish, that's part of the reason we only have 300 species in Canada, because not all can, because fish are cold-blooded. They can't, warm themselves up. They exist at the same temperature as the water. There's some species in Canada like burbot, lake trout, ciscos that love cold water. And so, freshwater, even in winter, doesn't freeze all the way down. The water at the bottom of a lake or the bottom of a river is typically sort of 3 to 4 degrees Celsius. And there's some species in Canada that thrive. That's the best temperature for them. They're doing great all winter. Other species, so just sort of hang on to that time. They find an area that doesn't have a lot of flow. They don't spend a lot of energy. They don't hibernate like a groundhog does, where they, are completely not moving, but they just lower their activity to get through the winter. They feed a little bit, but they don't digest very well in those cold temperatures. But yeah, fish are just able to get through the winter just fine, as long as the body of water that they're in doesn't freeze solid. And that only happens in, really small lakes and ponds that don't have fish populations.
I love that no matter what kind of creature we're talking about, if you have Canadian classrooms, they will ask how things survive the winter. We've got hard winters up here sometimes. So great query, guys.
Mm-hmm.
You showed all the spawn earlier. So we've got like a bazillion eggs and sperm and everything else. How many of those babies become adult fish? Do we have a proportion on that? Is there any knowledge?
Yeah, I mean, it again depends on the fish, because some fish that aren't migratory are nest garters. And so the adults will stay with the eggs until they hatch, and even guard the young for a little bit in a little school until they're big enough to be on their own. And so they'll have a bit of a higher survival rate. For salmon and other species that leave their eggs, it's usually less than 1%. Really what you're hoping is that every female that lays a nest of eggs, that at least one female comes back out of that as an adult to replace it. Typically, if there's not overfishing and if conditions are good, you'd have years, because they're so dependent on floods and on temperature and so on. You might have some years where none of those eggs make it back, and other years where 4 or 5 adults for every nest laid make it back. So you can have good years and bad years, but it's not a lot. Out of millions of eggs, you might have 1 or 2 adults. Yeah, exactly.
I love when we highlight this, because as people, we're so used to like, oh, 2 parents have 1 baby or 2 babies and they grow up to be adults no matter what. And we're in the minority there. Like a lot of insects, a lot of fish, a lot of reptiles, amphibians will have just endless babies. Certainly trees and plants will put, a million seeds out in the hopes that one will actually become an adult tree. So there's 2 very distinct paths that sort of creatures take on this planet. And I love when we get this for something that's not quite like us. So thanks, guys. All right. A really broad strokes question. Why do fish migrate at all? Why not just stay where you are?
Right. Well, there are fish that stay where they are, and there are fish that migrate. And so fish are going to migrate because there is, a resource that they can use in another area. And so migration allows them to, it allows those salmon as adults, they get into these fresh waters, they can dig a nest in the gravel, which they wouldn't necessarily be able to do out on the seafloor. They bury their eggs in that gravel, so it protects them, so more of the eggs hatch. The juveniles, when they rear, they can eat all of these little aquatic insects and so on. But the places that those juvenile salmon are born wouldn't have enough food to raise a 50-pound king salmon like that, right? So they need to go to a place where there is a lot of food, and they can just drift down those rivers, end up out in the ocean where there's all kinds of herring and smelts and all kinds of small-bodied fish that help Pacific salmon grow from this big one spring to 2 years later they're a big full-size salmon, and they're ready to outmigrate. So fish will move for other reasons, but typically it's to have the right resources that they need at the right life stage to maximize their growth rate and their survival. They want to maximize growth rate because as a fish, everything wants to eat you. And so the bigger you get, the fewer big things there are out there that can eat you, right? You get too big for anything else to eat. So fast growth is important.
A lot of adults will know the phrase, there's always a bigger fish. Like no matter what you are, there's something that's coming to get you. We don't really have this problem. Not many things want to eat us, but I guess kids, think of your home, think of your classroom. You have different needs in different places. If you just stayed in your home all the time, it would be hard to get out to get food. So you've got to go and move somewhere. And I love this question. Thanks, guys. Nick, time flies when you're having fun. We are nearing the end of the broadcast. Is there a way for our students, if they wanted to become you, what should they do? Is there a favorite part of what you do? Is there a career path, like sort of educational path they should take? Lay it on us.
Yeah, I mean, I love what I do, but I can't say that I love school all that much, right? I love being out fishing, being out in nature, and that's where I wanted to spend all of my time. I just realized that to do something like this where I could be working out in nature or working to conserve nature, that school was going to be a necessity, right? So even though it wasn't my favorite thing to do, I worked hard enough to be able to get to university. I took environmental sciences, but you could take biology, you could take zoology, you can be a part of conservation through the social sciences. And so you can take environmental studies or really any pathway if this is the sort of work that you want to do. The harder you study and the further you go, the better grades you get, the more choice you have. So that was for me, not really knowing what I wanted to do. I wanted to keep my options open, and I was willing to put that harder work in when I was younger to get to where I wanted to be today.
What a fantastic message. We don't hear this very often from our speakers, so thank you very much for being candid in that way, because again, sometimes school can be really challenging. Sometimes certain elements of it can be not what you're particularly interested in. When I was in school, I remember, biology classes for me weren't that interesting because I'd done so many programs. I'd looked at David Attenborough, DVD, Steve Irwin, and I was like, man, this is really getting me down. But if I want to become what I want to become, it's really, really important. So some of you might love every element of school. Some of you might have some troubles with it. But again, the message of if you are passionate about something and it requires an educational path to get there, put in the work and you end up with a job like Nick. So you get to work with the coolest people and go in the Yukon River and share your amazing work to hundreds of kids from around the world, which is a pretty great gig. So Nick, we will leave it there, man. I just want to highlight again for anyone, check out the amazing Canadian Wildlife Federation site, our full series all week long. We've got whales, butterflies, pronghorns, something else that I'm missing right now that I forget, but check out the series to learn more. And I really encourage you, IUCN, Reverse the Red as well, some really amazing programs to learn about conservation initiatives the world over. But with that, thank you so much for tuning in, everyone. Bye for now, and we'll see you soon.